Okay, so welcome everyone. Today's video is going to focus on the topic of solubility and how to tell whether or not a compound is soluble in water. So for a little bit of background, double displacement reactions, those are the ones where both compounds trade their partner, just like in square dancing, everyone still is paired up. In double displacement reactions, we generally run these reactions in water. This is because the reactions go much faster. Now, sometimes when we mix two solutions together, nothing happens. That means they're inert. They do not react. But the majority of them do something. They have a chemical reaction. Now, there's different things that we will see. The most common ones is that we'll either have a gas or formation of bubbles, or we will get a precipitate to form, a solid compound forming out of those two liquids. And we can determine whether or not a precipitate will form using something called the solubility rules. Okay, so just a few quick general solubility guidelines. These are much simplified compared to the complete set of solubility rules, but they're a very good rule of thumb to use for most situations. So first of all, compounds containing the following species are always soluble. And the way I think about this is, okay, I know it's a little cheesy, but all nitrates, acetates, ammonium, and alkali metal compounds are always soluble. That's always true. Now, the second part of this rule is compounds containing the following compounds are generally insoluble, okay? So these I think of as COPs. Now, we can't look at the names for this, but if you look at the polyatomic ions, it makes sense because you see that C, O, P, and S. So to remember these two rules, I remember, COPs. Okay, again, I know it's cheesy, but just go with it. So these compounds having carbonate, hydroxide, phosphate, and sulfide are generally insoluble. The exception to this is if they contain anything from Rule 1. Because remember, Rule 1 is going to supersede Rule 2. So if I have both a sodium and a hydroxide, well, sodium's an alkali metal. Hydroxide's on that list of things that are generally insoluble. But sodium, being part of Rule 1, is more important. So we know that sodium hydroxide is going to be soluble overall. Okay, so go ahead, try these out, think about it. If it has something from Rule 1, it's going to be soluble. If it has something from only Rule 2, then we know it's going to be insoluble. Okay, so I'm going to have you pause the video, try and figure this out. Then we're going to go over the answers in a few seconds, and don't look at that chart yet. Okay, pause the video. Okay, so hopefully you paused the video, you've tried this on your own, so let's go over the answers now. Okay, so calcium carbonate, if we look here, it has that carbonate, okay, that's CO3, but it doesn't have anything from Rule 1. So calcium carbonate we would expect to be insoluble. The next one, copper sulfide, okay, specifically this is copper 2 sulfide. Well, sulfide again is Rule 2, so that one's also going to be insoluble. The next one, ammonium hydroxide. Well, it has ammonium from Rule 1, so we know it's going to be soluble. We don't even care about that hydroxide being there because Rule 1 supersedes Rule 2. The next one, magnesium nitrate. Again, nitrate from Rule 1, so soluble. Then magnesium hydroxide. Okay, magnesium's not on list 1, Rule 1. Hydroxide, though, is on list 2, so that's going to be insoluble. And then finally, lithium sulfate. Well, lithium's an alkali metal, so that's also going to be soluble. Okay, if you have questions on this, circle them, and we'll talk about it in class. Now, that's just a general rule of thumb. There are always exceptions in chemistry. So we do have tables and charts. We can look up these compounds. You can look here where the two things intercross, and that will tell you whether some things are soluble, slightly soluble, meaning they kind of dissolve, but not completely, and then if they're completely insoluble. Okay. Now, if you look at these, you're going to see they follow really well with that Rule 1 and Rule 2 that I told you. So that's what we're going to use for most things in class, including tests and quizzes. I'm going to expect you to have those rules memorized. But know this is in your notes for when we do things like labs or in-class practice. Okay, so the reason why we care about solubility rules is we can use this to determine the phase labels for double displacement reactions. Okay, so if a product is soluble, okay, something from Rule 1, that means it will remain dissolved in water. If it's dissolved in water, we describe it as aqueous. So we're going to put that phase label AQ after it. If the compound is insoluble, that's another way of saying a precipitate will form. When this happens, we're going to label the product as being solid because it's no longer dissolved in that water. Okay, so let's go ahead and work through an example. You see this one isn't balanced, so we want to go through and work through balancing this equation. We're then going to add the phase labels. Now, if you look down below, you notice I set my atom inventory according to polyatomic ions. So I have the nitrate and the chromate here. Okay. So if we look here, we see initially that my silver isn't balanced. So let's go ahead and balance that first. So I'm going to put a 2 in front of my silver nitrate. And that changes both my silver and my nitrate in my atom inventory. After I look at this, I'm looking pretty good, but I see that I need a 2 on my product side and for my potassium nitrate. Okay, and with that, my chemical equation is balanced. So there's my nice, neat equation with no extra blanks for the coefficients. So now we want to look at the two products. Now, for this reaction, I'm going to tell you that we know it actually occurs. So one of these things must form a solid precipitate, and one of them must stay in the aqueous phase. Well, if we look at the first thing we come across, we see potassium. Okay, well, potassium is an alkali metal, so we know that it must therefore be soluble. We go to the next ion in that formula, we see nitrate, which we also know according to Rule 1 is going to be soluble. So I can go ahead and put that AQ afterwards. If we look at the next one, we see silver and chromate. Those don't appear on either list 1 or list 2, so I could look at that chart, or since I told you we know we're going to have one thing that's a precipitate, that's going to end up being my solid. Okay? If you have any more questions, again, circle this so we can talk over it more in class. But I look at the two products, compare them to the rules, figure out which one's going to be a solid and which one's going to be aqueous. Okay, so I have 2 problems I want you to try. For both of these, go ahead and balance them and then figure out the state of the products. Again, one of them is going to be aqueous and one of them is going to be a solid. So go ahead, try both of these questions, and then we will talk about them tomorrow in class. Bye, everyone.